Now let us solve a couple of examples based on the trigonometric identities that we learned so far. Now here is a question in which without using trigonometric tables we have to find the values of cos 75 and sine of 105. Both angles are in degrees. Now if you observe here, the angles are not the standard angles that we are aware of, like 30 degrees, 45 degrees or 60 degrees and so on. So now we have to think of how can we arrange or how can we bring 75 degree with the help of the known angles. So let us consider the first problem, that is finding out cos of 75 degrees. We can write 75 as addition of 45 and 30, both of which are the standard angles, isn't it? And we have seen the formula for cos of a plus b, that is addition of two angles. So that is equal to cos a cos b minus sin a sin b. So here it turns out to be cos 45 cos 30 minus sin 45 sin 30. And we know all the values. So cos 45 is 1 by root 2, cos 30 is root 3 by 2, minus sin 45 is again 1 by root 2 and sin 30 is 1 by 2. So that clearly gives us root 3 minus 1 upon 2 root 2. Similarly, if we want to calculate sine of 105 degrees, we can write 105 as 60 plus 45, right? Both are standard known angles. So therefore here the expansion of sin a plus b is to be used. So that is equal to sin a, that is sin 60 cos 45 plus cos 60 sin 45. So once again putting the values of these standard ratios, sin 60 is root 3 by 2, cos 45 is 1 upon root 2 plus cos 60 is 1 by 2 and sin 45 is once again 1 upon root 2. So therefore since denominator is common, we add the numerator, and here we have root 3 plus 1 whole upon 2 root 2. So in this way we can find out the trigonometric ratios of any compound angle which is composed of the standard angles. Let's go ahead to the next question. Here we have to prove that tan of pi by 4 plus theta is equal to 1 plus tan theta upon 1 minus tan theta. So clearly we are going to use the identity of tan of a plus b in the left side. So therefore let's write the left hand side, that is tan of pi by 4 plus theta. So tan of a plus b is tan a plus tan b upon 1 minus tan a tan b. So that gives us tan pi by 4 plus tan theta divided by 1 minus tan pi by 4 into tan theta, the product in the denominator. So that is clearly tan pi by 4 is nothing but 1. So we get 1 plus tan theta upon 1 minus, since tan pi by 4 is 1, we are left with simply tan theta as the second term, so which is nothing but the required RHS, right? Let's move on to another question. Now here we have to prove tan 5a minus tan 3a upon tan 5a plus tan 3a is equal to sine of 2a upon sine of 8a. Right? Now here if you observe the connection between the different figures, that is 5, 3, 2 and 8, we can immediately sense that 5 minus 3 is 2 and 5 plus 3 is 8. Right? And on the right side we have entirely sine terms, that is there is no cos or there is no tan. So if we think of 2a as 5a minus 3a, and if we think of 8a as 5a plus 3a, so that gives us a hint that we have to arrange sine of sum of two angles 5a and 3a and in the numerator also we have to arrange sine of 5a minus 3. So therefore if we simplify the left hand side, let us write tan as sine upon cos. So therefore we have sine 5a upon cos a minus sine 3a upon cos 3a whole divided by sine 5a upon cos 5a plus sine 3a upon cos 3a. So if you observe, if we merge the denominators in numerator as well as denominator, the denominators of both of them are going to be the same, that is cos 3a into cos 5a. So merging those and cancelling out the denominators, we have directly sine 5a cos 3a. Remember, the cross multiplication will happen in the numerator's numerator minus cos 5a sine 3a, and in the denominator we will have once again the cross multiplication in its numerator. So therefore that is sine 5a cos 3a plus cos 5a sine 3a. So once again, just to repeat, where does denominator go? So the denominators are going to be the same for numerator as well as denominator, so they are going to get cancelled ultimately. So that's what we have not written there. And if you observe the numerator now, it is sine a cos b minus cos a sine b. So clearly that's the expansion of sine of a minus b, which turns out to be sine of 5a minus 3a, and denominator is sine a cos b plus cos a sine b. So that can be written as sine of a plus b, which is here 5a plus 3a, and hence we get sine 2a upon sine 8a as required.